Welcome everybody to this data analytics portion of the data fluency training. My name is Andrew Pease. I am the Senior Director for Advanced Analytics in AIM. And over the course of the next 20-30 minutes, I'm going to talk to you about what you need to know about data, about analytics, and about artificial intelligence so that you can have those compelling first discussions with customers as they go along their digital journey. So let's start with the learning objectives for today. We're going to go through an introduction to analytics. We're going to go through the concepts of data visualization and cognitive. We're going to talk about more advanced analytics, and then we're going to talk about what's next in these different domains. What do these terms mean for our clients? What does it mean for Deloitte? And how can you build out the digital roadmaps for our customers to help them along their digital journey? So let's start with analytics. There's been a lot of hype about analytics and what analytics are. It's been all over the news. The term data scientist has exploded in the last 5 years. And who actually is a data scientist and what that mythical beast is subject to a lot of interpretation. It's been called the sexiest job of the 21st century by Thomas Davenport, who, by the way, also works for Deloitte. Technology and big data are changing the retail world. We see that with the advent of online retail channels and how brick and mortar retailers are trying to adapt to that changing digital world. We even see it in topics like the World Cup, trying to predict who is going to win based on the data. And then we also have the doomsayers. Elon Musk is saying that artificial intelligence is a great threat to our existence as humanity. And I think that the topic of ethics and how artificial intelligence fit into the broader scheme of society and how our organizations work is a key discussion point moving forward. Whether it's hype or whether it really will help our customers do something is a key discussion point that we need to take with our customers. And we need to be informed about the different trends involved in order to be able to lead those discussions. So let's talk a little bit more about what's happening and why are we doing this and focusing on this now. There's a lot of ways of looking at what is happening right now. I think one of the really useful ways of looking at it is talking about the next industrial revolution. The first industrial revolution was really about automating mechanical processes, being able to do it faster, do it better, do it cheaper, just augmenting the power that is put into those tasks and the repeatability that is put into those tasks. And there was also a lot of worry at the advent of the first industrial revolution that there wouldn't be any jobs left for humans, and we can see how that has played out. The new technology is all about augmented intelligence, about the interactions between humans and machine intelligence. Being able to understand what's happening on the basis of the data that's available, to predict what's happening on the basis of the data and trends that are available, and to optimize, to be able to do the best thing with the resources that are available for the tasks at hand. Okay. So why is it so hot right now? Well, there's a convergence of sorts going on right now. There's a convergence of data. Data is exploding everywhere. Everybody's got one of these in their back pockets. And that's creating and receiving unprecedented amounts of data. I've heard somewhere that the amount of processing power available on one of these machines is equivalent to the mainframe that put men on the moon in the 60s. So that's a lot more data, a lot more, and that's the second thing, computing power that's available. Before, it wasn't conceivable to take those overwhelming sizes and shapes of data and to transform that, to intelligently filter that down to an actionable insights. But that is becoming possible now with cloud infrastructures, with different types of processing capabilities that allow for those types of analytics. And the final part is that this is becoming more democratic. that you don't have to have a PhD in statistics, although some background in statistics is always warranted. You don't have to have that PhD in statistics in order to engage in these types of analytics and to use these types of analytics to augment your enterprise activities. So let's see what we need to lay the bricks for a digital enterprise. And at the very bottom, we have the technological foundations, the infrastructures, and data management. And I feel bad that poor old data management always comes in at the bottom here, because in fact, for our data science endeavors, for all of our analytics endeavors, if the data management isn't right, then the analytics and the insights you take out of it will not be right. And so we're not going to get into too much detail about data management, but we have to take that good data management is a given and a prerequisite for good analytics and for anything involving artificial intelligence. And so concepts like data quality become very important. Crap in, crap out is a mantra used a lot, that if you don't have good quality data, reliable data, one version of the truth, then you're trying to build intelligence on something that isn't stable. Master data management, having one view of the customer, one view of your products, one unique view across the whole organization. Data lakes for bringing in new data sources to make sure that we're not limited to the data that's in our data warehouses, but that we are free to innovate and bring in new data sources. Open data, there's big initiatives to make data available to all different types of enterprises, to all different types of research firms in order to build better societies and to build better insights. Big data, cloud infrastructures, Internet of Things, where more and more devices will be generating data which can also be used and exploited. If we go to the next level, we talk about analytics, and we talk about advanced analytics like machine learning. And one of the key things that I hope everybody can take out of this is machine learning is a concept that's been around since the 1950s. But with that convergence of big data, of the processing power, and the democratization, we can take machine learning to the next level in organizations. What's important about machine learning is a machine can't learn without feedback. So anytime you think about using, for example, a predictive model in any business context, we want to make sure that we have those feedback loops so that that algorithm can continue to stay relevant. Very important. We talk about different types of analytics, recommender systems. Anybody who's gotten a recommendation on Amazon knows what I'm talking about here. What is the next best action in any particular business or societal context? Image recognition. So trying to see from photographic or even video images what's happening and identifying that automatically. Business intelligence, a concept that's been around for a long time. Reporting, taking the data and not just driving your business on gut instinct, but also what the data is telling you. And then we move on to human interaction. How are we going to interface with these different technologies, with the data? And making that more cognitive, meaning more interactive, having, for example, voice interfaces going to be very important. Having the dashboards, the reporting that make it digestible to a wider audience within the enterprise. Chatbots, the way we interface with organizations, that first line, the age of the frequently asked question sheet is dead. It should be all chatbot driven, that a customer or a citizen goes on a website and that initial intake is done automatically. And then once there's more advanced information required or more interfacing required, that you can then go over to a human agent. And making it visual. A picture is worth 1,000 words, and we'll talk more about visualization on some of the other slides. Okay, so let's start with that human interaction and talk about data visualization and the cognitive initiative. How do we define cognitive? Well, first of all, we talk about human-like sensing, and that's that image processing. We've done a case recently at the Port of Antwerp for identifying off in the distance when something emerges on the horizon. Is it a boat or is it a bird? And being able to determine if it's a boat, how big it is, and when it will be there in order to find a parking spot for it on the port itself. All different types of use cases can emerge from video and image processing. In the medical sector, for example, using medical image detection to find cancerous versus non-cancerous growths in medical images. Human-like sensing also is something that's behind sentiment analysis. So for example, if a customer makes a request or a comment or feedback on the website, to evaluate the sentiment. Are they positive? Are they negative? That already gives us an insight of what to do with that particular comment. We also have human-like interaction, where we talked about chatbots already, where we can do more automate much more intakes. For example, having a robot at the entrance of a particular organization to direct people to the right department or the right place within the organization. Having this humanoid assistance to do that. Then we talk about human-like learning, and we can use, for example, robotic process automation to take manual tasks and automate them, which will not only reduce the amount of work that has to be done by a human being, the menial task that has to be done by a human being, but also can reduce the number of errors that occur in them. We talk about human-like reasoning. I think one of the big, most prevalent and obvious use cases for artificial intelligence and human-like reasoning is the driverless car, and combining different types of algorithms in an interface that the car can then know how to behave on the roads. Now that we've defined cognitive, let's talk a little bit about what data visualization is. Obviously, we can't look at all the data. We have to make some sense of that. We have to intelligently filter that. And by making visualizations with that data, we can tell those important data stories to guide decisions, to give people within the organizations, within the enterprise, the right information to make the right decisions. Now, visualization has to be an instrument to experience and consume that data. It should be visual, it should be intuitive, and it should be inactionable. And we'll try to keep those concepts in mind as we talk a little bit more about what visualization and data visualization is really about. Now, there are certain ways that our brains function. We talk about pre-attentive attributes. And for example, the form of the presentation is very important. How big it is, how it's shaped, how wide it is, and how long it is. All of these are important considerations for a good visualization. The position. Certain people will react better to a graphic in the top corner. Some will react better in the bottom corner. Knowing your audience and knowing how to position things is very important. What kinds of shapes, what kind of positionings, what kind of groupings, the color choices. Also, do you want to have motion in your visualization? Motion is a very powerful dimension to use in visualizations, but if you use it too much, you can also create a sort of seasickness effect in your visualization. So really keeping that all in balance, all these pre-attentive attributes are very important in getting your visualization correct. So what are some tips for a good visualization? Well, knowing what to say, how to construct a good story, what are the elements in the data that you're really trying to pull out and emphasize, what are the trends? Using questions and answers to frame the context can be very useful. And of course, the right visualization type based on the data that really tells the story in the most efficient and intuitive way is very important. You don't want it to be too busy. I've seen dashboards where you have 20 different reports, a pie chart with 20 different slices in it. It gets very difficult to pull anything intelligible and actionable out of that. So you really want to make sure that the message is succinctly brought in as few visualizations as possible. Also that the visualizations are adapted to your audience. You want to make it interactive so that the people can self-help, that they can ask the questions that they want to ask by looking at subgroups, for example, for looking at different geographical regions. Making it interactive makes it more self-help and makes it that much more valuable. And finally, you want to just keep in mind what your viewer's eye is looking for and draw attention to the right elements based on color, based on shape, and other best practices. So data visualization is still evolving. For example, we talked a little bit before, we'll talk again about advanced analytics, but bringing advanced analytics into your visualization can make it that much more powerful. We can always show the visualization of the historical trends for sales for a particular product, but if we can then put a time series forecast to project what we think those sales are going to be in the future, and what we think the confidence intervals around those sales figures are going to be, that makes it much more powerful. It's more than just leaving it to the viewer to see what the trends are and to make an estimate of what the future trend is going to be. We also use some analytics to do that. Another important evolution is narrative science. So we've talked and we've emphasized the visual aspect of data, and it stays very, very important. But the human mind is also highly attuned to narratives. So more and more software is taking data and really constructing a narrative out of that. Full sentences describing this happened at that point in time with that much money, all those different things coming together in a narrative. So narrative science really being a part of where visualization is going. And there are other evolutions and revolutions occurring in data visualization. The ability to annotate, that the visualization itself becomes a discussion tool and a way to pass information back and forth, that you can put the annotations directly in the visualization environment. Chatbots we already discussed as a way of presenting visualizations and helping people to get to the relevant information via visualizations. And then finally, augmented reality, using different types of interfaces, iPads, big screens, and being able to really interactively work with the data to construct your own visualizations in a very augmented way. So hopefully that gives you a good overview of what visualization and data visualization is all about. Now let's talk a little bit about advanced analytics and what advanced analytics can mean in the digital evolution of our customers. Here we see a definition provided by Gartner, that advanced analytics is the examination of data or content using sophisticated techniques, typically beyond those of traditional business intelligence, to discover deep insights, make predictions, or generate recommendations. There's nothing in there about statistics. Now, statistics obviously play a large part of advanced analytics, but it's more about data in and getting some sort of an actionable insight out automatically. That's how I would like to frame advanced analytics. Now let's look at what types of questions advanced analytics can answer. We talk about 4 different levels of sophistication in which you can go with advanced analytics. We can talk about simple reporting, which is what we do with a lot of visualization. What happened? We can talk about descriptive analytics. Why did it happen? Were there simple correlations that can be used to explain why certain factors, why particular customers bought at a particular time, why certain citizens performed some action at a certain point in time? Then we can move into predictive analytics, where we take historical cases and we try to extrapolate when we think certain things are going to happen, when somebody is going to buy, when somebody is going to commit fraud. All different types of actions where we have historical cases, we can build predictive models to bring that into a clearer light. Then finally, we can go into prescriptive analytics, where based on everything we know about a situation, let's try to find an optimum. For example, if we talk about marketing optimization, we have a limited budget, We have different channels that we can contact customers with. What is the right place, right channel, right time, and the right message to bring to the right customer? And how can we do that in a constrained way, meaning that we respect our budgetary constraints? That's mathematical optimization, and that's what we're talking about with prescriptive analytics. As we see here, these can be applied across a whole range of domains: the customer, the workforce, over financial operations, over IT operations, over the whole supply chain, and also in risk domains. All of these different types of analytics are applied in all of these domains in different types of organizations. And trying to figure out where your customer is on this journey will be a key in helping them to get to the next step. Now, advanced analytics can help humans, can augment humans in two different domains. It can help in tasks that humans are good at, but are slow at, hate doing. And we could look at, for example, image classification. If I take, for example, manually sorting pictures, if we can train an algorithm to do that, it's going to be more effective and more efficient. And then the human people in the organization can work on more value-added tasks. Text summarization, voice recognition, these are other types of this type of advanced analytics. Now, humans are also quite bad at different types of tasks, and where advanced analytics can also help. For example, capturing multi-dimensional relationships. Like, we as a human being, we can think of the relationship between education level and income. Okay, but once you start adding more factors to it, it starts to become difficult to really find those multidimensional relationships. A computer can take the data and find those multidimensional relationships, which is really valuable in exploiting all your data for some of the business topics that we've already discussed. If you want to estimate the probability of a certain event occurring, fraud, not fraud, machine breaking down or machine not breaking down. These are some use cases that we're actually working on now with some of our customers. Building predictive models allows you to really predict when something's going to happen and to take proactive actions towards that. Can also reason without prejudices. Daniel Kahneman's written a lot about the different biases that impede our thinking when we try to think too fast. Computers don't have those biases, those inherent biases. And actually, we have to make sure that when we build algorithms that we don't build in the same biases that we use in our day-to-day thinking. The example I always use for that is, do we want to have credit scoring models that systematically make it difficult for single mothers to get credit? And I think we have to really find the balance to make sure that because we predict that a certain class is going to have more defaults, are we also making those loans too highly priced, and so there's going to be more defaults, and you see how it can have a cascading effect. So just to give an example that although predictive models can eliminate bias, we have to be actively thinking about to make sure that that happens. Also making very quick decisions. For example, in an online or a digital context, if we have to make a split-second decision, Google has to make hundreds of thousands of split-second decisions about where to place ads. They use all kinds of A/B testing to figure out the best place to put those, but those decisions occur in the time it takes for your screen to refresh. So anytime we're talking about those types of real-time decisions, it's usually going to take some form of predictive modeling, advanced analytics, or artificial intelligence to make sure that that happens. So let's talk a little bit about how this all works. So you start by defining your outputs of interest. We talked about fraud, not fraud. We talked about buy, not buy. And then you collect the data that you want to use to predict that. So let's take an example. Let's say we want to predict whether a particular fruit or vegetable is a tomato, a potato, or a broccoli. We have some training data where it's labeled. The first picture is a tomato, the second is a potato, third is a tomato, the fourth is broccoli. We could have thousands of records where it's all labeled. And then what we can do is let an algorithm figure out what's different about these. Now in these three cases, it's quite simple. Tomatoes are red, potatoes are brown, and broccoli is green. So that's simple enough. Any algorithm can figure that out quite quickly. Now, we're going to then take this model to interpret new cases. So what happens when that new case is a cherry, which is also red, but not a tomato? Well, the model is going to assume that it's a tomato. So that's an important consideration when you build predictive models. You have to make sure that your training data is representative of all the cases that you wish to score. And in this case, if we did it without any cherries in there, then we're going to incorrectly score cherries as tomatoes. We also want to talk, whenever we're talking about predictive analytics, we want to talk about feature extraction. Sometimes we can have thousands, even hundreds of thousands of variables going into a model. All the customer data that we collect, transactional, demographic data, all the big data sources that can give us insights into what a customer is going to do. But we want the models to be as simple as possible. And the real art in building predictive models is actually not in the algorithm you use, but it's in feature extraction, making sure that you have representative data and that you're not using, for example, two variables that are saying the exact same thing. In order to do this properly, you need to have some business knowledge, you need to have some data knowledge, and you need to have some data science knowledge. And yeah, you're probably not going to find one person who has a complete view of that in any context. So it's just important to make sure you have teams that have business sector knowledge, know where the data is, know how to combine the data, and know something about algorithms and the different techniques available in order to extract the information from that data. So now let's talk a little bit about how advanced analytics can create value. Who hasn't benefited from a weather forecast? We see here Frank, Flemish weather god, right? And how very rarely he gets it wrong, right? How hot is it going to be tomorrow? Hopefully some of you have also benefited from the Deloitte parking app, where we actually predict, based on the number of cars that are in the garage at a certain point in the morning, how many cars will be there an hour later. So you can use that to preemptively direct people to other parkings before it fills up. Now, the world of advanced analytics is also evolving very quickly. All different types of new algorithms, data gathering techniques. Starting with the algorithms, there's reinforcement learning, which is instrumental, by the way, in the driverless car. Use convolutional neural networks to recognize what's happening in front of the car, and reinforcement learning to figure out what happens next by rewarding certain outcomes like nobody getting run over, nobody getting killed, and penalizing other outcomes like in a simulation when one of those outcomes does happen. Deep learning, that's convolutional neural networks. And so it's a combination of those two that gives us the driverless car. And cognitive interaction is increasing. The ability, for example, to drive advanced analytics with voice technologies. Technology is also evolving. Faster processing, cloud infrastructures, more advanced analytics everywhere, building it into smarter machines, for example. Those of you who have your new iPhone, there's facial recognition in there. That's happening on your device. Where it's also changing is in the adoption and ethics. More and more organizations realize that artificial intelligence, machine learning, advanced analytics are becoming central to remaining relevant in a digital age. What also will stay important is the ethical considerations. And I think it's very important that we don't try to take distance from that as data scientists and say, well, the data says this, there's no ethical implication. Everything we do, there's an ethical implication. We have to consider that at both the organizational level and at the societal level. And GDPR is also one of the contexts where we're forced to do that. And I think that's great. GDPR isn't really just a mandate or something that organizations have to do. It gives them the opportunity to look at all their analytics assets, make sure that everybody in the organization is aligned from a strategic perspective, from a human capital perspective, and from a procedural perspective to make sure the analytics are being used in the way that is consistent with the strategic objectives of the organization. I hope this overview has been useful for you. What's coming up next is you'll try to build up a deeper understanding of some of these concepts in some hands-on exercises. So I hope you like the use case that we've developed for you, and I hope you have a good time working with your colleagues on those use cases. After this LinkedIn learning session, you'll have an interactive session with exercises, and you'll get a chance to apply that knowledge. If you have any more questions on any of these topics, or if you want to go deeper with some of your customers on any of these topics, please feel free to reach out to any of us from AIM. I'm more than happy to talk analytics with anybody. No question too simple or too complicated. We like a tough challenge, and we really want to help you to be able to drive the digital initiative in your customers through advanced analytics, data management, and artificial intelligence. So thanks very much for listening.